Welcome to WW2 Frontline Legends, where World War II history is brought to life. Here, forgotten heroes are remembered, untold stories are revealed, and never-before-seen documents speak for the first time. On this day, October 1917, Toledo, Ohio. Smoke hangs low in the cold Midwestern air. Oil burns somewhere nearby, sharp and bitter, clinging to the back of the throat. Inside a narrow brick workshop near the Maumee River, an engine screams at full throttle. The sound is violent and uneven, metal striking metal in a rhythm that feels wrong. The walls bear the scars of earlier failures. Chipped porcelain, dark scorch marks, slivers of ceramic buried in old timber like shrapnel frozen in time. The man standing beside the engine does not flinch. He watches the gauges with practiced stillness, eyes fixed on a trembling needle that climbs higher than it should. Heat pours off the block in visible waves. The air itself seems to bend. Any mechanic in Toledo would have shut the engine down by now. Any engineer would have called the test a failure long before this moment. But he lets it run. He knows what usually happens next. A sharp crack. A sudden silence. Another ruined spark plug. Another dead idea. Another reminder that engines, like men, are being pushed beyond what they were ever designed to endure. This is not just a test. It is a countdown. And what fails here will decide what flies, what stalls, and who lives when the war finally reaches its most mechanical form. If stories like this matter to you, subscribe to WW2 Frontline Legends and tell us where you are watching from around the world. In 1917, engines are becoming the backbone of modern war. Trucks move artillery. Tanks grind forward through mud and wire. Aircraft climb higher and faster than anyone believed possible just a decade earlier. But beneath every advance, beneath every daring maneuver, lies a fragile weakness that few outside engineering circles truly understand. The spark plug. Small, replaceable, easy to ignore, and catastrophically unreliable. Inside early internal combustion engines, temperatures surge toward levels that defy the materials of the time. Approaching 2,000 degrees Fahrenheit, the combustion chamber becomes a furnace where metal warps, insulators fracture, and sparks fail without warning. Pilots trust engines that can betray them mid-flight. Mechanics swap plugs by instinct, not confidence. Engineers argue endlessly over stronger alloys, thicker electrodes, tighter tolerances. None of it solves the real problem. The man in the Toledo workshop understands this, though he struggles to put it into words even for himself. He has watched steel expand too fast. He has watched metal crack under stress it was never meant to survive. He has seen engines fail not because of poor design, but because heat moves faster than human assumptions. The war has accelerated everything. Production lines, expectations, consequences, and failure now carries a different weight. Somewhere across the Atlantic, pilots take off with engines assembled by strangers. Somewhere on a muddy road in France, a truck stalls under fire because a spark vanished at the wrong second. These failures are recorded as accidents, as bad luck, as inevitable losses of war. But in this workshop, surrounded by broken ideas, one engineer refuses to accept inevitability. He is not famous. His name does not appear in newspapers. There are no medals on his wall. What he has instead are notebooks filled with diagrams that most men would dismiss at a glance. Sketches of insulators shaped in unfamiliar ways. Margins filled with temperature curves and expansion rates that do not match conventional wisdom. While others chase stronger metal, he studies something most engineers avoid. Ceramic. To his peers, the idea borders on absurd. Ceramics are brittle. They shatter under vibration. They crack under stress. They belong in laboratories, not inside engines that shake violently thousands of times a minute. The consensus is firm and confident. Ceramics cannot survive inside a working engine. But consensus has failed him too many times. He notices what others overlook. Heat does not destroy everything equally. Materials expand at different speeds. Metal grows fast and unpredictably under extreme temperature. Ceramics expand slowly, carefully shaped, carefully seated. They resist the very forces that tear metal apart. The problem, he believes, is not strength. It is isolation. For months, he works in near secrecy. Not because he is hiding something grand, but because no one is interested in listening. Suppliers grow tired of his small orders and strange specifications. Fellow engineers shake their heads and offer polite advice before turning back to more respectable problems. Money runs thin. Failures pile up. Each test leaves evidence behind. Fragments of porcelain embedded in the walls. Burn marks across the workbench. The lingering smell of overheated oil that never fully fades. Neighbors complain about the noise, about the explosions, about the risk. He keeps going. Late nights blur together. Sleep becomes optional. He measures, reshapes, recalculates. Some tests fail instantly. Others last long enough to tease hope before collapsing into silence. The engine becomes both enemy and teacher, revealing just enough truth to keep him chasing the next attempt. By late 1917, the margin for error disappears entirely. His funds are nearly gone. Suppliers stop returning his letters. The war effort demands results, not theories. Every failure feels heavier than the last, not because of pride, but because time is slipping away. And then quietly, without ceremony, something changes. A ceramic core survives. Not for seconds, not for minutes, for hours. The engine screams through the night, heat building far beyond what any spark plug should endure. The gauge climbs past familiar danger zones, past the point where metal deforms, past the threshold that has ended every previous test. And nothing happens. No crack, no fracture, no sudden silence. When he finally shuts the engine down, the workshop falls into an eerie quiet broken only by cooling metal ticking softly in the dark. He approaches the engine slowly, almost afraid to look. The ceramic core sits where it should, intact and unbroken. No carbon leakage. No visible damage. The impossible has occurred. The temperature has exceeded 2,000 degrees Fahrenheit, and the spark never failed. This should be the moment everything changes. The moment he celebrates. The moment he writes letters, files patents, demands recognition. Instead, he does something no one expects. He destroys the evidence. The ceramic core is smashed. The fragments swept away. The notes from the test remain incomplete, deliberately vague, as if the success never fully existed. In his records, the breakthrough is reduced to ambiguity. Because even as the engine ran, even as success unfolded in front of him, he felt something else. Pressure. He is not alone. Unknown to him, interest has been growing far beyond his workshop walls. Across the Midwest, a young company is quietly expanding its reach, acquiring patents, studying failures, listening closely for rumors that do not fit established limits. Champion, still building its reputation, has heard whispers of an impossible spark plug. One that does not crack. One that does not melt. One that survives where others fail. And whispers travel faster than inventions. The engineer senses this before he understands it. He notices unfamiliar questions from suppliers. Subtle changes in tone. Requests for materials he did not order. Someone, somewhere, is piecing together the same puzzle from a different angle. So he retreats inward. He tests less. He documents less. He keeps his success close and his silence deliberate. Whether out of caution, fear, or foresight, he chooses not to speak. Outside his workshop, the world races forward. Engines become more powerful. Demands increase. The war shows no signs of slowing. Every improvement carries consequences far beyond the drawing board. What he does not know yet is that the idea has already escaped him. Fragments of ceramic from earlier failures have traveled further than he realizes. Samples sold, resold, examined by hands just as curious and far better funded. Engineers elsewhere begin to test shapes that resemble his abandoned sketches. They notice the same slow expansion, the same resistance to heat, the same quiet defiance of accepted limits. Inside the Toledo workshop, the engine sits cold now, silent and waiting. The man stands alone, surrounded by broken pieces of ideas that almost worked and one that worked too well. He cannot yet see what comes next. But the spark he created will not remain confined to this room. And the war is about to find out what happens when an engine finally stops failing. The silence after success does not last. In the weeks following that night in Toledo, the workshop becomes quieter, but the pressure around it grows louder. The engineer senses it before he can explain it. A feeling that the walls are no longer just holding in heat and noise, but secrets. That something has shifted not only inside the engine, but outside the room. Across the Midwest, industry is accelerating at a pace unseen before. Factories run day and night. Rail lines pulse with shipments of steel, copper, rubber, and fuel. Every improvement is measured by one standard alone. Can it help win a war that refuses to wait for perfection? Champion is watching this transformation closely. Still a relatively young company, Champion understands that reliability will decide more than races and commercial engines. It will decide supply lines, air superiority, and the margin between mission success and mechanical disaster. Their engineers sift through reports of failures the way battlefield commanders study maps. Patterns emerge. Heat remains the enemy no one can defeat, until rumors begin to circulate. They are vague at first. Whispers from suppliers. Stories of ceramic insulators behaving differently than expected. No proof. No finished product. Just fragments of possibility that refuse to disappear. Champion does not ignore whispers. They send quiet inquiries. Not confrontational. Not demanding. Simple questions disguised as curiosity. Some suppliers answer too freely. Others do not realize the value of what they have already sold. Among these transactions are ceramic samples, imperfect and incomplete, but enough to spark interest in minds trained to see potential where others see waste. Back in Toledo, the engineer feels the change without seeing its source. Materials he once ordered easily now arrive late or not at all. Letters go unanswered. Familiar names begin to vanish from his contact list. It feels as if the ground beneath his work is subtly shifting. He doubles down on silence. If success exists only once, it can be dismissed as luck. If it exists twice, it becomes a target. So he tests less, documents less. He spends long hours staring at the engine without running it, as if by stillness alone he can freeze the moment that gave him everything and nothing at the same time. But innovation does not respect ownership. In Champion's facilities, engineers begin recreating conditions that mimic the failures plaguing early spark plugs. They test metal after metal, alloy after alloy. All fail the same way. Too fast, too hot, too fragile when it matters most. Then the ceramic samples are introduced. At first, they shatter, just as everyone expects. But not always, and not in the same way. Some resist longer than they should. Others fracture cleanly instead of exploding. Subtle differences appear, the kind that only emerge under obsessive scrutiny. The breakthrough does not arrive all at once. It emerges slowly, uneasily, through dozens of failed recreations. Shapes are adjusted, thickness altered, seating refined. The ceramic is no longer treated as an afterthought, but as the central element around which everything else must adapt. The same realization dawns on them that once haunted a small workshop in Toledo. The problem is not strength. It is control. As Champion's engineers refine the design, the implications become impossible to ignore. An engine that no longer fails unpredictably changes everything. Maintenance schedules, mission planning, risk tolerance. Suddenly, aircraft can fly longer. Trucks can travel farther. Tanks can push harder without fear of sudden silence under fire. This is not an incremental improvement. It is a structural shift. And it is happening without the man who first saw it coming. When Champion finally approaches the engineer, the meeting is polite, restrained, almost cordial. They do not accuse. They do not confront. They ask questions he knows how to answer and others he refuses to touch. He denies success, denies breakthroughs, denies anything beyond routine experimentation. But the denial comes too late. Champion already knows. They have tested enough to confirm the theory independently. The ceramic core, properly shaped and seated, can survive temperatures that would destroy traditional designs. They do not need his notes. They do not need his permission. And they do not wait. Production begins quietly at first. Limited runs. Controlled distribution. The ceramic spark plug enters engines without fanfare, its significance hidden beneath layers of steel and grease. Mechanics notice fewer failures. Pilots notice smoother runs. Reports shift subtly, then unmistakably. Engines stop dying without warning. This is the moment where history tilts, unnoticed by those living inside it. If you are still with this story, subscribe to WW2 Frontline Legends and tell us where you are watching from. These turning points often pass without witnesses. The engineer learns of the production indirectly. A mechanic mentions a new plug that does not crack. A supplier hints at increased orders he did not place. Pieces of the puzzle assemble themselves with cruel clarity. The invention has escaped him. Whether through oversight, inevitability, or deliberate restraint, control has shifted elsewhere. Champion's version is not identical to his, but it does not need to be. It works well enough. And, in wartime, well enough is everything. What troubles him is not the loss of credit. It is the consequence. He understands something many do not. Reliability extends wars. It sustains momentum. An engine that does not fail allows plans to stretch further, pushes men deeper into danger, gives commanders confidence to demand more. An unreliable engine forces caution. A reliable one invites ambition. He wrestles with this in silence. There are no letters to write, no protest to file that would change the outcome. The machinery of war is already absorbing the innovation, grinding forward with renewed confidence. Champion spark plugs begin to appear in more applications. Aircraft engines that once required constant attention now run longer between failures. Supply trucks travel routes once considered too risky. Tanks move with fewer mechanical stops, altering the tempo of ground operations. No single report credits a ceramic insulator, but collectively, they reshape expectations. In design offices and hangars, the conversation shifts. Engineers begin planning engines under the assumption that ignition will hold, that the spark will be there when demanded. This assumption seeps into strategy, then doctrine, then habit. And habits are hard to reverse. Subscribe to WW2 Frontline Legends if you believe moments like this changed the war more than battles did. Back in Toledo, the workshop grows colder. The engine sits unused for longer stretches. Dust gathers on benches once scorched by constant experimentation. The ceramic fragments embedded in the walls remain, silent witnesses to a success that refused to announce itself. The engineer does not disappear immediately. He continues working, but without urgency. The chase is over. The idea has moved on without him. Whether he feels relief, regret, or something darker remains impossible to know. What is clear is that the spark plug he imagined is no longer just an object. It is a decision. Champion refines the design further, standardizing production, ensuring consistency. By the time the United States edges closer to full involvement in the next global conflict, the ceramic core is no longer experimental. It is infrastructure, and infrastructure rarely remembers its origins. If this revelation surprised you, subscribe to WW2 Frontline Legends and share where you're watching from. History often hides its most important turning points in plain sight. As the years pass, records thin. The engineer's name fades from internal memos. No patent battle erupts. No dramatic confrontation ever occurs. The absence itself becomes part of the mystery. Did he choose silence to avoid responsibility for what came next? Or did he simply understand that once an idea proves itself, it no longer belongs to its creator? By the time the world plunges into full mechanized war, engines roar with a confidence that would have seemed impossible in 1917. They climb higher, run longer, fail less often. And deep inside those engines, a ceramic core quietly does what it was never supposed to do. It survives. The war will soon demand more than anyone expects. More power, more endurance, more faith in machines to carry human lives into places where failure is not an option. And somewhere between invention and inevitability, one man's decision continues to echo. Not loudly, but endlessly. The world does not notice when the transition is complete. There is no announcement, no headline, no ceremony. By the time engines begin starting reliably in places they never had before, the change already feels normal. Mechanics stop bracing for failure. Pilots stop listening for the stutter that once warned them the sky was about to betray them. Commanders stop factoring ignition breakdowns into plans that now stretch farther, faster, and deeper than ever before. Reliability becomes invisible, and invisible things reshape wars. By the late 1930s, the ceramic spark plug is no longer a curiosity. It is embedded in the machinery of modern conflict, quietly enduring temperatures that once destroyed entire missions. Aircraft climb higher without hesitation. Trucks move through dust and heat without stalling. Tanks grind forward with fewer mechanical pauses, their momentum no longer dictated by fragile ignition systems. What began as a private obsession in a Toledo workshop now lives inside engines across continents. And yet, the man who first understood what heat truly demanded is nowhere to be found in the official story. Records thin out after the early years. The workshop closes. The engine that once screamed through the night falls silent for good. The ceramic shards remain embedded in wood and brick, slowly gathering dust, while the world outside accelerates toward another global war driven by machines that finally trust their own spark. History prefers clean narratives, clear inventors, clear victories. But this story resists closure, because what the engineer understood was never just technical. He understood timing. An engine that fails forces restraint. It limits ambition. It injects doubt into plans built on speed and power. An engine that does not fail invites escalation. It encourages longer flights, heavier loads, bolder routes. It allows war to move faster than reflection. As the Second World War unfolds, this quiet shift reveals itself not in single moments, but in accumulated endurance. Bombers reach targets once considered marginal. Supply convoys travel longer routes without interruption. Naval patrol aircraft stay aloft when they once would have returned early. None of this is attributed to a spark plug. It is attributed to progress. The irony is sharp. The invention meant to solve a mechanical problem becomes part of a larger moral equation. One that weighs reliability against consequence, efficiency against endurance, success against what success enables. By the time historians look back, the trail is cold. Champion's production records tell a story of refinement and scale, not origin. Wartime documents list specifications, not doubts. The ceramic core becomes a standard component, stripped of mystery by repetition. But some absences are louder than presence. There is no patent dispute, no memoir, no recorded interview where the engineer explains his choice to step back. The silence invites interpretation. Some argue he was simply outpaced by industry. Others believe he recognized the weight of what he had unlocked and chose obscurity over ownership. What remains undeniable is this. Once the sparks stop failing, the war stops slowing down. The machines learned to endure. And once they did, human decisions followed. In hangars across Europe and the Pacific, ground crews work through the night preparing aircraft that will fly farther than crews once dared. Engines start with confidence. Ignition systems fire cleanly under conditions that once guaranteed failure. Every smooth start reinforces the belief that machines can be trusted to carry men into danger and back again. That belief shapes doctrine. It shapes strategy. It shapes the length and intensity of conflict. The engineer never sees the full arc of this transformation. There is no record of him watching bombers lift into the sky, powered by principles he discovered. No evidence that he followed the war closely at all. Perhaps distance was deliberate. Perhaps it was necessary. Because the ceramic core does not choose sides. It does not distinguish between missions meant to defend and missions meant to destroy. It simply survives. In that survival lies its power. As the war grinds on, reliability becomes an assumption baked into every plan. When something fails, it is treated as an anomaly rather than an expectation. This subtle shift alters how risks are calculated, how losses are justified, how far leaders believe they can push both machines and men. Progress no longer asks permission. It demands utilization. Long after the last engines of the war fall silent, the ceramic spark plug remains. It moves from military applications into civilian life, carrying the same quiet resilience into peacetime machines. Cars start reliably in winter. Industrial engines run hotter, longer, more predictably. The technology outlives the context that gave it urgency, and the moral question fades into background noise. The workshop in Toledo never becomes a museum. No plaque marks the place where heat was finally confronted instead of feared. The absence itself becomes symbolic. The origin remains scattered across fragments, supplier records, and half-remembered stories passed between engineers long after the man himself is gone. What survives is the effect. A small component that changed how engines behave, changed how wars unfold. Not by firepower, not by speed alone, but by endurance. And endurance is a dangerous gift. Because when failure disappears, restraint often follows. This is the uncomfortable truth buried beneath the ceramic core. The engineer may have sensed it before anyone else. He may have understood that solving one problem inevitably amplifies others, that making machines dependable removes natural limits that once forced pause. If that realization drove his silence, history never confirms it. But the timing suggests awareness. The spark plug that refused to fail emerged just as war demanded machines that would never hesitate. It arrived not as a weapon, but as a permission slip for ambition. And once granted, that permission was never revoked. Today, engines still rely on principles forged in that era. Ceramic insulators continue to manage heat the way metal never could. The solution endures, refined and replicated, its origins softened by distance. Yet the question remains unresolved. Did the engineer lose control of his invention? Or did he step aside deliberately, understanding that once reliability entered the equation, the world would never slow down again? That ambiguity lingers, inviting debate long after the engines cool. Because history often remembers battles, but it is shaped by decisions made far from the front lines, by people whose names vanish even as their ideas refuse to. And sometimes, the most powerful force in war is not the weapon that explodes. It is the machine that never stops working. If stories like this remind you that wars are shaped by forgotten minds as much as famous generals, subscribe to WW2 Frontline Legends and tell us where you're watching from around the world.